Hello everyone, this is Dr. Song. Welcome to my YouTube video. So today we have a quantitative research method, week 4, and then part 3 section. So we are now studying how you can obtain the normality of your continuous variables. And then we are using also the software SPSS to find that how you can obtain the result using the SPSS. So last session, we talked about the normality, the condition of the normality of the continuous variables. But first, before starting my course, I just want to tell you that this is the courses. I took the references to conceive my course, so you will know from where is coming my course. Okay, now normal distribution. So there are many conditions when you will say a continuous variable is normal distributed. The first condition was the n, so the participant should be the more than 30. So the sample size is greater than 30. And then also we saw that about how it was the histogram, how was the PP plot, and then also we saw the KS test. So that is the what we saw until the last session. Yeah, of course we saw also skewness and kurtosis also. So these are all obtained by using the SPSS. So just simply I want to go over again to show you the procedure how you can obtain until the KS test. So this is a data set, and then we need the one continuous variable to use that. So you will let's go to the variable view, and then you can see here the values when it's not defined with the nominal or the ordinal variable. All of them they are continuous variable because they are the scale variables. So you can see the satisfaction, burnout, turnover, all those like abstract concepts that should be like a operationalization of the definition, and then they have the normally it's of more than 5 and 6 questions, and all they are together considered as a total score, and then that becomes the one scale variable. So simply saying that you cannot ask the one question to find the satisfaction. You should ask at least 5 and 6 questions, and the total sum of those questions that becomes the how you will interpret the satisfaction of your participants. So these are the scale variables. Today I will use the satisfaction. So to see if your data here, the satisfaction, yeah, you have the numbers here, and then how you will know they are normally distributed or not. So that is what we want to do with the SPSS. You will go to the analyze and then descriptive statistics, and then you go to explore. So this procedure I showed you last time, but we will go over just again. And then you put the satisfaction in your dependent list, and then you go to the statistics, and then you will check the outliers and the percentiles because I want to show you how you will relate those concepts. And then continue, and then the plot, and then you will check the histogram instead of a stem and leaf, and then also normality plot with test. That is a KS test. So continue, and then okay. So that generates the many information about the normality. So first, you will know how many people were. So it's greater than 30. So that is satisfied. And now you have here skewness and kurtosis. So about this, I told you that when you divide this number by the standard error of the skewness, and then if that is a greater than the plus minus 1.96 or plus minus 2.58, you will consider that is a skewness is not assumed. So kurtosis is the same. So 0.148 divided by the 0.328. And then if the number is greater than plus minus 1.96 or 2.58, you will consider that skewness and kurtosis, they are not assumed. So normality already is a problem when that becomes like that. You will calculate this. I will not go to details because we have some limited time, but you can calculate. Now, percentile. So if you remember, when we obtain the range, like a maximum value minus the minimum value, sometimes that can be not correct one, because if you have the excessive score, that will change your, how can I say that, the range score. So last time I showed that if there is a minimum is a 10, maximum is 100, and then 100 minus 10 is 90, so there is a big difference. So that can change the, in fact, the real value of the your range value. So to prevent that, we will obtain the percentile. So that is a 25%, 75%, and this is a 50%. So when you obtain the 72 minus 61, that means that is a third quartile, and then minus first quartile. That will be the interquartile range. So that is a more exact reality of your data. So 72 minus 61, that obtained the 11, and then 11 multiply by the 1.96 plus minus 1.96, and that is the range of the your range, in fact. So you can accept the plus minus 1.96, and that will be, I will just show you what is that. So here, yeah. So that will be the like the maximum score, like a third into quartile, and then this is the first quartile, and this is the average. And now when you calculate that, the average plus minus uh, interquartile range, so this one minus this one, and multiply by the 1.96, you will obtain the maximum and then minimum score here. So you will obtain the this and this. If the scores are going to the under or the over, and then you can consider that is outliers, that is extreme scores. So that's why I'm talking about this one here, the percentile. That is they shown very easily by the outlier graph. So you will consider that 25, that is the first quartile, 75 third quartile, and this is average. And then you deduct the 75 minus 25, and then that should be multiplied by the 1.96, and then the result will give you about this line, maximum and the minimum. Okay, so that is the I wanted to explain about the percentile. And then you can see that according to that maximum and the minimum, you will compare if those extreme values, like extreme values, if that is over or under. So if that is not over, you can just keep them. But if you like this lowest value that is much under the minimum value, that becomes the real outlier, and you have to think about how you can deal with those scores. So if you obtain the very low value, considering the your minimum value, the one solution is a wingerizing. So wingerizing means that you will take the score that is most close to the your minimum value. So for instance here, if you can see that that is a very close to the minimum value, so those are not like a very very extreme score, but you can think about here, for instance, 44 or 46. So you will winterize that with the 39, 42, 43, 44 as a 46. That means that you will take the value is most close to their value, and then you will change the value is this one, 46. That is a winterizing. That is one of the solution you can take for outliers. And then now normality. You have the significance is a 0.03. So this one is a bit greater than 0.01. So you will accept that as the normality is assumed. Because you know the KS test is a very rigorous test. So that should be the greater than 0.01, and this one is 0.03. So that means that is greater than 0.01. So you accept the your null hypothesis. Null hypothesis is normality, the data is normally distributed. So you can accept that. And you can see now that is also, it's not bad. You can give a double click, and then you can draw the line of the normality. Yeah, so you see, it's not it's a bit skewed negatively, but not too much. So you can accept that. So in fact, you can see that that is fine, histogram, and you can see also the PQQ plot that individual scores are almost on the line. So that is normally distributed. And then you can see that there are some outliers is under the minimum, but we said that we will linearize them. So you can include the inside of the over the minimum value. So you will not have the really the serious problem with the outliers. Yeah, so that is the what we saw in the last session about the holding things. And now we have to talk about convert to the Z scores. Why? Because Z scores that shows the where the individual scores are situated. So that means that you will know the what is the outliers. So that's why we can find the data scores for the outliers. But already you saw the here we can deal with the this explorer option, and then you can linearize that if that is too much low. You can see here, yeah, this one. If too much low, you can find the just the score which is most close. So that's why, in fact, when you run the SPSS, what is the most important to do is the normality. First, you go to the analyze and then descriptive and the explore. Yeah, and you go there, and then statistics. You will check that outliers as the percentiles. I think this is very important to judge how you will deal with and also you will understand your data. So you continue that, and then plot a histogram, and then the normality plot test. This is like a default, so you don't have to check. But I think this and then this you have to check. Yeah, and then you can just click OK and to run the test, and then you will obtain the these informations. So this one, descriptive, percentile, extreme value, test of normality result, and the histogram, and then QQ plot. This is not really important. You can just focus on the QQ plot. And then finally, the outlier. Yeah, your outliers, you can find that in the box plot. Yeah, so this is what I wanted to show for today because we had some time to explain about the until here. Next time, I will explain about how you can convert it to the data scores. We did that last time, but I think I will go again. So the just in the SPSS, if I just repeat what I did last time, you can analyze and then descriptive and then descriptive, and then you put your variable satisfaction here, and now you don't touch this, just save the standardized value, and then you do OK. And then you will see in your data, yeah, in your data, in the end of your data, you have the new variable. That is a Z satisfaction. So here you can see the -2, 1, etc. These are the Z scores. Okay, these are the Z scores, and then they are showing that how each individual score is situated in your data. So that I want to explain next time about the Z scores. Thank you so much for today, and then see you soon. Bye.